Hi everybody, and welcome to another exciting advanced presentation in Chemistry 125. The things that we're going to be doing today is going to be extremely exciting. It is kind of going to attempt the impossible, and we're going to create a fireproof balloon. Now, that we know is that balloons are actually extremely fragile, which is why normally we want to keep them away from flames as well as sharp objects, just because most of the time they will end up popping. But before we get started, there's just a couple things that I want to cover, and one of those things is thermal conduction. So thermal conduction is the ability for a medium to allow heat to be conducted through it. This is the transfer of internal energy by microscopic collisions between particles or between electrons within an object. As we know, heat will normally travel from a hot point to a cold point. For example, if we have a metal rod and we end up heating up one end of the metal rod, more than likely that heat will actually travel all the way through to the point where the entire metal rod will be heated, because it travels from a hot point to a low point. That will be really important in this experiment as well, especially when we are talking about our fireproof balloons. One of the other things that we need to talk about is heat convection. This is the transfer of heat by mass motion of fluids such as air or water. This normally will take place in our balloon when each of the water particles, is heated and will actually move from the top of the balloon to the bottom as it heats. Just like our metal rod example. So as the water at the bottom of the balloon start to heat up, they will actually travel up and will kind of replace the cold water in simpler terms. Once heat convection is done taking place, all the particles should be heated at about the equal amount of temperature to the point where the balloon, at some points, can even start to boil. When this does occur, the balloon will actually end up popping, because there is a thermal equilibrium between the water and, of course, the flame. So one thing that we need to know is that if you have a balloon that is filled with air, which I have right here, it will eventually pop. It will pop without any flame or anything in it. The reason for that is because as the rubber gets heated, the balloon actually without water will become so hot that it will become too weak to resist the pressure that is inside the balloon. So some of the things you're going to need, as I mentioned, is a balloon with air in it, which I have already blown up. You're going to be needing a balloon with water. I filled this one just about right there. It does not have to be filled all the way. And of course, you're going to be needing a candle. And you're going to be needing I right here have this fancy torch, but just a match or anything like that will work. So one of the first things that we're going to need to do is turn on our flame. And so first we're going to see if we can pop just the balloon filled with air. I'm a little scared of balloons, so this is going to be scary to me. So I don't like this. Okay, so as you can see, the reason why it popped is because the actual, the balloon couldn't resist the pressure that was inside it because of the heat. However, let's reheat this. Set this back on fire. Wait for the flame to get kind of big. So you will then take your air and water-filled balloon, and you're going to slowly lower balloon to the flame candle. When you do this step, it is really important that you keep the bottom of the balloon above the flame. The reason for that is if you end up tilting your balloon, it could actually eventually pop because the flame will be greater than the water's ability. So let's see here. As you can see, we have a fireproof balloon. Just like that. Your balloon will eventually turn black. The reason for that is because there is actually soot that is formed because of the incomplete combustion. And it is normal to see that the balloon will burn, of course, with the match. So, as we know now that fireproof balloons is the result of water being a great substance for soaking up heat. Water actually has a really high heat capacity, which means that As the thin latex balloon allows the heat to pass through, the water will actually grab that heat and will just slowly begin to warm up. As the water closest to the flame heats up, it will begin to rise, and the cooler water, of course, will then be replaced to the bottom as the hot water moves up, as we mentioned in our explanation above. The cooler water will soak up all the heat and then will basically process itself and repeat itself. So one of the things that is important for us to know when we're doing this experiment is that thermal equilibrium is basically what is going to occur. And at that point, when it is reached, your balloon will not be fireproof anymore. Thermal conduction does not just take place when will not take place if there's no water particles in order to heat up, because there's nothing to really conduct energy to. But anyway, I hope you guys enjoyed it. The experiment seems pretty simple, but there's definitely some concepts that make it more complicated. I hope you guys had fun, and I hope you have a blessed day.